Let's solve this system and find the point of intersection using substitution. And part B, we'll use elimination. So first, we'll use the idea of substitution. We simply isolate for one variable to find the other. So it doesn't really matter. Why don't we isolate for y here? We'll divide both sides by 2. So we get y is equals to 4 plus 2x. So what is y? Y is 4 plus 2x. And we're going to substitute this y variable into the other equation. So the moral of the story is, given two equations and two different variables such as x and y, indeed we can find the exact coordinates of the point of intersection. We can find x and we can find y. So we're going to substitute in y. So we get 3 times y, which is 4 plus 2x, equals 12. So now it's simply a matter of algebra. We multiply. 3 times 4 is 12. 3 times 2x is 6x. 2x plus 6x is 8x. And 12 minus 12 is 0. Dividing both sides by 8, we have x equals 0. Now to find the point of intersection, we also need to find y. So we'll say when x equals 0, we can use either equation. We'll just use this one here. We'll substitute in 0 here. 2 times 0 plus 3 times y is equals to 12. Anything times 0 is nothing, 0. So 3y equals 12. Divide both sides by 3. We have y equals 4. So the coordinates of the point of intersection is 0, 4. I recommend that you visualize this system on Desmos. Now, this idea of substitution is a major technique in systems of equations. Let's focus on the second major technique, which is called elimination, and it doesn't really matter which technique we use. So to eliminate systems, I recommend that you align things in terms of x and y and the constant. So we'll say equation number 1, 2x plus 3y equals 12. That's great. Now let's rearrange this second equation in terms of negative 4x plus 2y equals 8. And we'll copy that down over here underneath. So we have negative 4x plus 2y equals 8. And the goal is to eliminate one of the variables. That's why it's called elimination. So now that we've aligned everything in terms of x, y's, the equal sign, and the constants, let's draw a big line underneath. In math, you're actually allowed to subtract equations or even add equations. So what we're going to do is we're going to multiply this equation here by 2. Because the idea is we want to eliminate the x's, or perhaps you can find try to eliminate the y's as well. We can try that after. So let's multiply the top equation by 2. So what we now have is 4x plus 6y equals 24. And I'm just going to copy the second equation here. Negative 4x plus 2y equals 8. And finally, we can add these two equations. If we subtract equations, we would get 4x minus negative 4x, which would become 8x. Nothing actually cancels out. So we're going to actually add the entire equations. 4x minus 4x added becomes nothing, 0x. I'm not going to write that down. 6y plus 2y is 8y. And when we add these two numbers, we get 32. Divide both sides by 8. We see that y equals 4. Now it doesn't really matter where we substitute y into. Let's just use this first equation here. We're going to substitute y equals 4. So 2x plus 3y equals 12. So we get 2x is equals to 2x plus 12 equals 12. 2x equals 0. So therefore, dividing both sides by 2, we get x equals 0. So as we can see, we found the point of intersection as 0, 4, the same answer that we got previously, using elimination. Let's use elimination one more time with the same question. We had 2x plus 3y equals 12 as our first equation. In our second equation, we had negative 4x plus 2y equals 8. This is a bit silly to do it this way, but we're just going to practice. We're going to find the LCM of 3 and 2 to eliminate the y's, even though it probably makes more sense to eliminate the x's. So the LCM of 3 and 2 is 6, so let's try to get the equation number 1 to be a 6y. So we're going to multiply equation number 1 by 2, because we want the LCM of 6. We want the y's to cancel out. So we get 4x plus 6y equals 24. And we're going to multiply equation number 2 by 3, because that way we'll get 6y. So we have negative 12x plus 6y equals 24. And in math, we're allowed to subtract entire equations. Let's take the bottom equation minus the top, or top equation minus the bottom. Doesn't really matter. We'll just go top minus bottom. 4x minus negative 12x, two negatives become a positive. So 4x minus negative 12 becomes 16x. This minus this becomes 0y. I'm not going to write that in. 24 minus 24 is 0. So 16x equals 0. So therefore x equals 0, dividing both sides by 16. So once you have x, you could substitute into either equation to find y. And as you can see, we're getting to the same answer as we did previously.